Hi, this is Sung. I'm the Principal and Director of Sky Academy. We've been going through the chapter on Locus, right? And in particular, we've been now going through some examples of typical Locus type questions. We went through for, I think it was the last 2 episodes, questions that really involved using the distance formula. I mean, that's the most common use of a formula when doing Locus type questions. However, we also need to be able to use some of these other formulas, right? And this is going to be a situation where we use the gradient formula and the parallel perpendicular line properties or relationships, okay? So let's have a look at the question that we're going to be looking at and see if you can pick up why we use the gradient formula and the parallel perpendicular lines properties. All right, so let's have a look at this particular question. Find the equation of a locus of a moving point P with coordinates x, y, such that angle APB is a right angle for the points A being 4,2 and B being -2,8. Okay, so in other words, what we've got to do is pick some arbitrary point P, right? That will be a point on this exact locus that will meet the criteria or the conditions that are set out in this question, right? Which are that the point P and the angle that it makes with B and the angle that it makes with the angle that APB makes, so in other words, the line PB and the line AP, right, are going to make a right angle, right? So can you see off the top of the bat that what we are going to be using is the gradient formula? Because what we've got to try and do is show that the gradient of PB and the gradient of AP are perpendicular to one another. Because if they're perpendicular, they're 90 degrees. Then the angle APB is 90 degrees, right? So what we've got to do is we've got to work out an expression for PB and we've got to work out an expression for AP, right? Or the gradients of PB and the gradients of AP. Okay, so before we launch into the algebra, can you actually see what this locus is going to be? All right, let me give you a hint. All right, this line AB is going to be, all right, the makings of a right angle triangle with point P, all right? Now, let me give you a hint. For those of you who are doing extension 1, well, this will only really apply for those people doing extension 1. And if you've done circle geometry, right, that's the hint. Circle geometry will say that the angle subtended by the diameter inside a semicircle, all right, or a circle will always be a right angle, yes? So basically, what will the locus of P be? It's gonna be a circle or a semicircle. Can you see that? All right, but we're gonna work that out, all right? We're gonna work out that, all right? I just spoilt the fun. So what we've got to do is work out the conditions. The conditions are the gradient M of AP times the gradient of BP is going to give us -1, all right? Which is a way of stipulating the geometric condition for this locus, all right? Which is another way of expressing the fact that the angle APB is going to be a right angle. Got it? All right. So what is the gradient of AP? All right. Well, it's obviously going to be y2 minus y1 over x2 minus x1. All right. So y2 is your y, x2 is your x, your y1 in this case is going to be your 2. Your x1 is going to be the 4, all right? Okay, now the gradient of BP is going to be y minus 8, x minus 2, all right, or negative 2, right? So you've got y minus 2 over x minus 4 times y minus 8 x, and this minus and minus make a plus, plus 2, and that's going to give us minus 1. Do you see that? Good. So let's work that out. Y minus 2 times y minus 8, expand that out, that gives us y minus, or y squared minus 10y plus 16 all over x squared minus 2x minus 8 equals to minus 1. Now, this comes from experience, right? Me being able to kind of just work that out quickly. But if not, take the time to just go away on a piece of on a piece of paper or on a pad. Just work that out yourself using the FOIL method. Yes? All right. We take the bottom and we're going to multiply the bottom by minus 1. All right. And that gives us y squared minus 10y plus 16 equals to minus x squared minus 2x minus 8. Yeah? Then we're going to take this bit and bring it into the bring it to the left-hand side. When we bring this over to the left-hand side, because we're going past the equal sign, all right, on the other side of the equal sign, this minus will become a plus. Got it? So we've got y squared minus 10y plus 16 plus x squared minus 2x minus 8 equals to 0. Yeah? So this minus, when we bring it across the other side, becomes a plus, which means that we can preserve all the signs of everything inside the brackets, because this minus becoming a plus will apply to all of this, right? So in other words, we can keep all of that, the signs that they are inside the bracket. All right, so that becomes that, all right? It's starting to look like a circle, yeah? Which is what we want, because we know the answer is going to be a circle, all right? So let's work out where the center is, and let's work out where the radius is. This comes from a process of completing the square. So let's take this and this. 16 minus 8 is positive 8, and bring that over to the other side. It's going to be negative 8, all right? So it's y squared minus 10y and plus your whatever it is that's going to complete the square, plus x squared minus 2x plus whatever it is that's going to complete the square, all right, is going to be equal to, and what is it? What do we say? 16 minus 8 is positive 8. When we bring it over to the other side, it's going to be negative 8. Does that make sense? Good. All right, so what do we have to add here to complete the square? Well, we've got to halve the 10, or the minus 10, which is minus 5, and square it. We add 25. Yep. So if we add 25 to the left, we've got to add 25 to the right. And I'm breathing a sigh of relief here, because we want this number to be positive, otherwise we don't have a radius, yeah? And given that we're adding 25, yeah, I'm breathing a sigh of relief, because we're starting to move into the positive area, all right? Positive territory here. Now, the other expression, or the other constant that we're adding to complete the square is x squared minus 2x. Take the coefficient of the middle term, minus 2, halve it, minus 1, square it, which is again positive 1. We're adding 1, which means we're adding 1 here. All right, so that means this becomes y minus 5 squared, all right, plus over here, this bit becomes x minus 1 squared, which is going to equal 25 plus 1 is 26, minus 8 is 26 minus 8 is 18. Yeah? Good. All right, so that actually tells us that the equation of this circle, is going to be center. All right, so it's a circle. Let's write down the fact that it's a circle with center equal to 1, 5, not 5, 1, because remember this is the y coordinate, this is the x coordinate, 5, 1, 5, yep, and radius is equal to root 18. Now, root 18, right, I can work this third out. The root 18 is basically 3 root 2 is your radius. Okay, good. Now, let me just stop there, all right, because what you will find, right, is that this point here should satisfy this equation, and this point here should also satisfy this equation, all right? Let's work that out, okay? And this is a little sneaky trick here. Let me come around this way. All right, so basically let's substitute the point 42. 2 minus, all right, is that 2 minus 5 is -3. -3 squared is 9. 4 minus 1 is 3. 3 squared is 9. 9 plus 9 is 18. See how this point satisfies this equation? This point here should also satisfy the equation. All right, so we've got 8 minus 5, which is 3. And you've got minus 2 minus 1, or -2 minus 1, which is -3 squared, which is 9. 9 plus 9, again, is 18. But what I want to ask is, are this point and this point part of our locus, right? In other words, at point A and point B, will that be part of the condition that we're trying to meet, all right? So in other words, P, right, can't actually equal to A and B, and in fact, if P were to equal A and B, you wouldn't have an angle APB, would you, right? So actually, the answer is, it's the circle with this equation, with center 1, 5, and radius 3 root 2, excluding the points A and B. Does that make sense? So in other words, it's going to be a whole circle, right? But you've got 2 missing points, this point here and this point here, okay? So that's basically a little trick, right, that you need to be aware of when doing this particular question. Okay, thank you very much for watching.